Searching is a process of finding a particular record, which can be a single element or a small chunk, within a huge amount of data. The data can be in various forms: arrays, linked lists, trees, heaps, and graphs, etc. With the increasing amount of data nowadays, there are multiple techniques to perform the searching operation. Various searching techniques can be applied on the data structures to retrieve certain data. A search operation is said to be successful only if it returns the desired element or data. Otherwise, the searching method is unsuccessful. Linear search is a method for searching for an element in a collection of elements. In linear search, each element of the collection is visited one by one in a sequential fashion to find the desired element. Linear search is also known as sequential search. Start. Begin at the first element of the collection of elements. Compare the current element with the desired element. Found. If the current element is equal to the desired element, return true or index to the current element. Otherwise, move to the next element in the collection. Repeat steps 2 to 4 until we have reached the end of collection, not found. If the end of the collection is reached without finding the desired element, return that the desired element is not in the array. In linear search algorithm, every element is considered as a potential match for the key and checked for the same. If any element is found equal to the key, the search is successful and the index of that element is returned. If no element is found equal to the key, the search yields no match found. Consider the array and key equals 30. Start from the first element, index 0, and compare key with each element. Comparing key with first element. Since not equal, move to the next element. Comparing key with, still not equal. When comparing with key, the value matches. So the search is successful and index 2 is returned. Applications of linear search: algorithm, unsorted lists, used when the list is not sorted. Small data sets, preferred when the data size is small. Searching linked lists, commonly used to find elements in a linked list. Simple implementation, easy to understand and implement. Advantages of linear search algorithm: works with unsorted arrays, no additional memory required. Well suited for small data sets. Disadvantages of linear search algorithm: time complexity is O of n, hence slow for large data sets. Not suitable for large arrays. Time and space complexity of linear search algorithm: time complexity, best case O of 1, worst case O of n, average case O of n, auxiliary space O of 1. Binary search is a search algorithm used to find the position of a target value within a sorted array. It works by repeatedly dividing the search interval in half until the target value is found or the interval is empty. Divide the search space into two halves by finding the middle index mid. Compare the middle element with the key. If the key matches the middle element, return the index. If the key is less than the middle element, search the left half. If the key is greater than the middle element, search the right half. Repeat until found or the interval is empty. Consider an array like this: 2, 5, 8, 12, 16, 23, 38, 56, 72, 91. Now let's say our target is 23. The first step is to check the middle element. If it's not equal to our target, we need to determine which half of the array to search next. We repeat this process until the element is found. Applications of the binary search algorithm include being a building block for machine learning algorithms. It's also used in computer graphics, for example, in ray tracing and texture mapping. Furthermore, it's quite useful for searching in databases. The advantages of the binary search algorithm are numerous. First, it's faster than linear search for large datasets. It's also efficient for large datasets stored in external memory, such as on a hard drive or in the cloud. Additionally, it's more efficient than interpolation or exponential search in many cases. Now let's talk about the disadvantages of the binary search algorithm. It requires the data to be sorted, which can sometimes be a drawback. It also needs the data to be in contiguous memory, and importantly, the elements must be comparable, meaning they need to be orderable. Moving on to the time and space complexity of the binary search algorithm. For time complexity, the best case is O of 1, the average case is O of log n, and the worst case is also O of log n. When it comes to auxiliary space, it's O of 1 for the iterative version and O of log n if it's recursive due to the call stack.